this question says, consider the reaction. 2HI gas yields H2 gas plus I2 gas. At a certain temperature, it obeys this rate law, and we're given the rate law. Suppose a vessel contains HI at a concentration of 1.46 molar. Calculate how long it takes for the concentration of HI to decrease by 86%. You may assume no other reaction is important. So basically what we have here is we're given a rate law, and in this case we want to find time. In previous videos on this playlist, you'll find where we use the integrated rate law to find the concentration after some time, but in this case, time is the variable. So the first thing we need to do is use the rate law to determine the integrated rate law. Since there's no number here, that means this is first order. So we want to use the integrated first order rate law, which says ln of the concentration of HI after some time is equal to negative KT plus the ln of the concentration of HI at time 0. So this is the integrated first order rate law for this particular question. Note that this has somewhat of a different form than what you see on ALEKS, and I want to show you how they get the form that you see on ALEKS, and then we'll solve it. So if we want to rearrange this so that we can solve essentially for T, the first thing we need to do is get this ln of concentration HI0 on the other side. So subtract ln concentration HI0. And what you end up with is ln of the concentration of HI after some time minus the ln of the concentration of HI at time 0 equals negative KT. Now, because these are logarithms, which are essentially the exponents, it's a natural log, so base 2.303 or whatever it is, we basically have exponents here. So since we're subtracting the exponents, this is the same mathematically. Subtracting logarithms, or natural logarithms, is the same as dividing. So we can rewrite this as the ln of concentration of HI divided by the ln of concentration HI at time 0 equals minus KT. And we can further simplify this to the equation that they show on ALEKS, which is ln concentration HI over concentration HI0 equals minus KT. So this is essentially the equation that you see on ALEKS. Sorry, I should pull that down. As we simplified it through. So subtracting logarithms is the same as dividing, because these are the exponents, and dividing exponents, when you divide exponents, you subtract. And also we can simplify the ln of the ratio equals minus KT, so we don't have to take the ln of both. It's basically the same thing. So now the question becomes, well, what do we plug in? Well, K is pretty obvious, because K is going to be the 2.26 seconds to the minus 1. But we're not given concentrations of HI and concentrations of HI0. To be fair, we are given a concentration of HI0, but then we want to see what happens when it decreases by 86%. So there are several ways to do this, and I want to prove it to you. So I do want to show you how I would do this. But then I'll show you could just plug in 0.14 for this ratio, and I'll show you why. So we need to find this ratio. I'm going to skip the logarithm for a second, the natural logarithm for a second. I just want to find this ratio. So I want to find the concentration of HI over the concentration of HI0. Well, we know the concentration of HI is 1.46 molar. What about the concentration of HI0? Or excuse me, we know the initial concentration HI0 is 1.46 molar, because it says, suppose a vessel contains HI at a concentration of 1.46. We want to know how long it'll take for it to decrease by 86%. Well, if it decreases by 86%, that means there's 14% left. So we take 1.46 times 0.14. And if you want that as a number, it's 0.2044 molar, and we can plug that in. Not surprisingly, when we take this ratio, this is 1.46 and this is 1.46 times 0.14, the ratio of these two numbers is 0.14. So the ratio of what's left is 14%, 0.14. So in order to solve this, we want to plug in the ln of 0.14, what's remaining, equals minus kt. K is 2.26 seconds to the minus 1, so it's the ln of 0.14 equals minus 2.26 seconds to the minus 1 times t. The ln of 0.14 is minus 1.966 equals negative 2.26 t. Divide by negative 2.26, divide by negative 2.26, and t equals 0.87 seconds. To briefly recap, we first found the integrated first order rate law. We then rearranged it so that we had the concentration of HI after some t over the concentration of HI initially. We then realized that 14% was this ratio because 86% was the decrease, was how much was consumed, which means the ratio that was left to what there initially was 0.14. We then simply solved. Note that in these examples, there are also examples with second order rate laws, and you would have to solve this out in a similar way, but it's not done exactly the same way because you don't have the logarithms involved. So that's how you solve this particular problem.